previous class. I'm going to give you a question from NCERT. That is, draw all the eight structural isomers that have molecular formula C5H11Br. Also, name H isomers according to IUPAC system. And classify them as primary, secondary, and tertiary. So, Hemam and Austin, are you aware of this structural isomers?
Yes, sir.
Did you say Austin, yes or no?
Yes.
Okay, please draw it. There is hint in the question that with this formula you will get 8 structural isomers. Any structure you have drawn? Any one of you?
Yes, sir.
What is the name?
So bromopentate.
Okay. How many structure you have drawn till?
4.
Okay. Name name the next one.
3 bromopentate. 2
Then
bromopentate.
very good. Mom, what about you?
I found 2.
Let me know when you are done with this. So I'm going to draw this. 5 carbon is there. So I'm just 1, 2, 3, 4 carbon, 5 carbon, like this. So these three are very easy. Basically, are you able to understand this, the bond and structural formula, both of you? Mom,
Yes, sir.
Yes, sir.
okay. The name is also quite easy. 1, 2, 3, 4, 5. So 1 bromopentane, or you can write directly bromopentane. Then here it will be 2 bromopentane. And then it will be 3 bromopentane. Now we need to draw 5 more structure. Now you just need to move, since we move all the possible position for bromine. Now we are going to move methyl. So I'm going to write it like this. 1, 2, 3. Okay, like this. Bromine here at the first position and methyl here. You can see easily. The name will be 1, 2, 3, 4. Okay. So the name will be 1 bromo, 3 methyl butane. 1 bromo, 3 methyl butane. The next one is you can see like this. Bromine I'm gonna move here and methyl as it is. So its name will be 1, 2, 3, 4, and hence the name will be 2-bromo, 2-methyl butane. Now the next one is also very easy. Mm, Just wait a minute. How can we draw this? Three methyl. Okay. Bromine here and methyl is also here. So its name will be 1, 2, 3, 4. The numbering now, the name will be 2-bromo. Okay, this has a name. I got it wrong. 2-bromo, 3-methyl. This is because methyl is at third position. Now these are both on the second position. So 2-bromo, 2-methyl butane. So how many structure now we are done with 6. Now we need to go for 2 more structure, which is also very easy. Now I can write like this. 1-bromo, 2-methyl. Are we done with this? No. So bromine here and methyl here. So you can see 1, 2, 3, 4. So the name will be 1-bromo, 2-methyl butane. Butane. And the last one, which is very, very easy. No, not like this. Just wait a minute. Bromine is here and methyl, I'm gonna make it first. So 1, 2, 3. Its name will be 1-bromo, 2, 2. Isomers are very easy. Same molecular formula, different structural form. So C5H11Br has this much, this, 8 structural isomers. And for the degree of halogen, this is your primary, this is your secondary, this is also your secondary, this is your primary, this is your secondary, this is your tertiary, this is primary, this is also primary. Yes or no?
Yes.
Just let me know when you are done with this. Please do write it. Both of you done with this? Mhm. Are you done with this?
1 second, sir.
Okay, take your time.
Done, sir.
Very good.
So in the last one, there'll be 12 hydrogen atoms, right?
And the last one, this one,
Yes, sir.
3 plus 3 plus 3, 9. There is no hydrogen to this carbon because it already making 4 bond, right?
Oh, yes, sir.
9 plus 2, 11. Okay.
Yes.
Now see, whenever you are going to write the name, okay, I'm going to give you the first trick for the numbering, basically the rule. If you have functional group, I think you are aware of this functional group, yes or no?
Yes.
So functional group like alcohol, aldehyde, ketone, carboxylic acid, and all amine, and all ester. So you are going to give the preference for numbering to the functional group first. If functional group is done, if you are done with the functional group, then go for multiple bond. Multiple bond, that means double or triple bond. And in this multiple bond, you are going to give preference first to the double bond and then triple bond. Are you getting my point?
Yes, sir.
Yes.
This is the numbering. This is for numbering. Okay. And then you will go for what we say, then you will go for substituent and also for the counting escalate number of carbon in escalate. Okay. Basically chain with maximum number of carbon. Okay. Chain with maximum number of carbon. This will come first. Basically, let me chain with maximum number of carbon. Okay. Now, if you don't have any functional group, then you will, if you have double or triple bond, you are going to give numbering. This is for numbering because numbering is very important, and you do the you do write the nomenclature according to IUPAC. Got it, both of you?
Yes, sir.
Yes, sir.
And when one or two same groups repeated, then you are going to write the number. If it is repeated twice, then you are going to write the number twice. If it is present on the same carbon, like on the second position, you are going to write 2 comma 2 and you will use di. If it present at two different positions like 2 and 3, so 2 comma 3 di, and if it is methyl, dimethyl. If it repeated thrice, then you are going to write the position 1 comma 2 comma 3 if it is like this, and then tri. For 4 you are going to write tetra. Got it?
Yes.
Okay. Now I'm going to give you some question which is quite not confusing. If your concept is clear, you can do this easily. These questions are from NCRT basically. right? IUPAC names of the take your time, but do it correctly. Whenever you are going to answer me, just cross check it once and then this is very important. Please do it. Any answer? Oh, very good, Austin. What about you, Mom? See, I'm going to explain the post. Okay. You can number from here. You can give numbering from here. But you cannot jump to this carbon directly. See, basically start from the end. Either you can name From the top, you can see this or this. If you are going to number it, sorry, not name, numbering it from here, 1, 2, 3, 4, 5. 5 number of carbon you are getting in your chain. And if you are going to number it from here, 1, 2, 3, 4, 5. Umam, what do you think? The numbering should be done from bottom to top or top to bottom? What do you think? No, you are not audible. Am I audible to you also? From?
I'm not sure, but I think I'm not sure.
Whatever is in your mind, just answer me. What do you think? From
From
top to bottom?
From top.
From top to bottom. You know why? Because if you are going to number it from top to bottom, the double bond gets the second position. The double bond starts from where we take its position. And if you are going to number from bottom to top, the double bond is getting the third position. So what of numbering? There is no functional group. So we will directly jump to the double bond. The position from where the double bond gets lowest number, from there we are going to number it. Okay. So from top to bottom is the right one. So I'm going to do this. Now you can see now 1, 2, 3, 4 and 5. You have this branch only. This hydrogen, we don't name it. Basically, we don't consider hydrogen as a branch. Okay. We just saw it to make you confused. Okay. Now, what will be its name? Always, I told you, whenever you are going to write the name, you are going to name. How do you write the name? First, you are going to write the name of the branch or substituent. Branch or substituent with number. Okay. And then you will jump to the parent chain. How many number of carbon present in the parent chain? Then you will jump to the multiple bond, like double bond, triple bond, alphabetically basically. And then nature, basically, just wait a minute. Okay. And then you will write the like multiple bond, and then nature, basically multiple bond, or you can write nature of bond, and then you can write the functional group at the end, functional group. So you can see you have only multiple bond, double bond. So first you are going to write the name of the branch. What is the branch? Fourth position. And what is present? Bromine. So 4 bromo. Then you will go for parent chain. How many number of carbon? 5 carbon. So pent. You are going to write pent only. Then nature of bond, you will see double bond present. What is the position? Second position. So its name will be pent 2 ene. For double bond, we write ene. Yes or no?
Yes.
No. 3 bromo 25. Very good. For the second one, I'm going to explain. See, if you are going to write the number 1, 2, 3, you need to take double bond. If you are going to write the number, you can write this as well. But you have to leave this double bond, because double bond is not, you are not counting. Double bond should be in between. If you are going to count 1, 2, 3, 4, double bond on the left hand side, you are going to leave it. So how I'm going to write? Always remember, whenever you are going to write the numbering, whenever you are going to do the numbering, functional group, there is no functional group. So you will just concentrate on double bond. First carbon is there, 1, 2, 3, 4. Okay, you cannot go 1, 2, 3, because you will get only 3 carbon in the parent chain. You have to take care, like double bond should get lowest position. There should be greater number of carbon in the chain. So it will be like this. Now you are going to write the name. On third position, you have bromine, and second position, you have methyl. Methyl M, bromine B. So we are going to write 3 bromo, then 2 methyl, and then how many number of carbon in the parent chain? 4. So bute. And what is the nature of the bond? Double bond at one position. So bute 1. Please do write it. Let me know when you are done.
Done, sir.
Very good. Now I'm going to give you more of this type of question. Please do it. And let me know if you're not able to. Any answer? Third one is 4-bromo 3-methyl pentene. Very good. And the fourth one is 1-bromo. Okay, fourth one, I think 1-bromo 3-methyl butene.
It's 2-methyl, sir.
It's 2-methyl, yes.
Yes.
Any answer from you, Kumar?
First one I got 4-bromo 3-methyl pentene.
Very good. Or the fourth one?
Fourth one I'm doing.
Please do it, and I'm gonna give the another question. Please do this as well. Very good, Austin. Very good. Are you done with the next one, Umam? This question
Yes,
number
sir.
4.
Yes, the fourth and fifth I'm done.
What is the name? Okay,
One
tell me the name
bromo,
of the fourth one.
one bromo, two methyl butene.
Very good. Go for the fifth one.
Fifth one is one bromo butene.
Very good. Please do sixth one as well. Please do write the structure of all these compounds. Then I will let me know. Then I will write the structure and match it. So yeah, you Oh, mom, let me know when you are done with the question number 6.
The sixth one I'm not getting properly.
The sixth one not getting totally not a problem. See, you need to do the numbering from where double bond gets the lowest position 1, 2, 3. Now, if you goes like this, you will get third carbon, 3 carbon only, and sub branch. So we will move like this. And now you can see the name will be At the third position, there is bromine, so we can write 3-bromo. And at the second position, there is methyl, so we can write 2-methyl. And how many carbon in the parent chain? 3 carbon, so prop. And you can see only one. At the first position, there is double bond, so prop 1. Got it?
Yes, sir. Got it.
Please do that. Let me know when you are done with the structure as well. Are we done with the structure?
So, in the second one, we should
Yes.
run hexane or
Heptane, third one, no? It is hexane.
second. Yes.
Hexane it is.
No, I mean, how should we do? Uh,
See, are you done with the first one?
yes, sir, I'm done.
2-chloro-3-methyl pentane. Whenever you are going to write the structure, concentrate on the main chain. Pentane, that means 5 carbon. 1, 2, 3, 4, 5. Now, you can see 2-chloro. So let's say 1, 2. So at the second position, you have chlorine. And at the third position, you have methyl. So this is the structure. You can also write like this, CH3, like this. Say 5 carbon in the parent chain. So what you need to do? 1, 2, 3, 4, 5. And make a single bond. Now at the second position, you have chlorine. At the third position, you have CH3 methyl. And at you are going to write satisfy the valence like this. Okay. For the second one, 1-chloro-4-ethyl hexane. Hexane, that means this. This is your hexane. You're going to write the chlorine and 1, 2, 3, 4. Fourth, you are going to write CH2, CH3 here. Got it? Austin?
Yes.
Austin, are you able to solve this? Yes or no? Yes or no?
Yes, sir.
Okay. Now see the third one. Heptane, that means 7 carbon. That means 7 carbon. So I'm going to write 1. And heptane, that means single bond. So I'm going to write single bond as well. No, sorry about this. Are you able to see the screen?
Yes.
Yes.
No. 7 carbon is there now. On fourth position, let's say this is your 1, 2, 3, and this is your fourth position. You have to give a branch. Tertiary butyl, that means that means you are going to write a structure with 4 carbon and it should be tertiary. So there is only one possibility. This is your butyl. You can see 4 carbon in the branch and it is tertiary with all of this. Forget about this. Isn't it tertiary if you are going to see this 3°? Because this carbon is connected with 3 carbon. Are you getting my point? Yes or no?
Yes, sir.
Yes.
Tertiary butyl is common now. And on third carbon, you have iodine. So you are going to write iodine like this. And at the rest part, you are going to write like CH3, you are going to satisfy the rest valency with hydrogen. Please do. Are you done with this? Still in the Austin, Humamuddin, are you done with this?
Yes, sir.
Yes, sir.
Okay. 3 more compounds I'm going to give you. 2 more compounds. Fourth one is 1,4. Di. This is D. Dibromo. Bio. Please do write. Will you be able to do this? Okay. Any answer, Austin?
So I did the fourth one, fifth one.
What did you say?
So I did the fourth one, but the fifth one I don't know.
Okay. So I'm going to explain the fourth one, then fifth one. Dibromobutane, that means 4 carbon and 2 ene. Let's say numbering, do the numbering in your mind, 1, 2, 3, 4. At second position, there is double bond, so I just wrote a double bond. 1,4 bromo. So 1. Got it. Now come to this. Benzene is there. 2-methyl benzene. So it's also very, very easy. I'm going to show you. This is your benzene. Everyone knows that, yes or no?
Yes.
And there is 2-methyl. Okay. 1 bromo. Let's say any place, at any place, this is your bromo. So 1, 2, 3, 4, 5, 6. And at the second position, there is methyl. So I'm going to write this methyl. And at the fourth position, secondary butyl. Butyl, that means 4 carbon, and you are going to write in the previous one, it was tertiary. That's why I made it like this. This is your tertiary butyl. For secondary butyl, what I'm going to do? CH3, CH, CH3. sorry, CH2, CH3. You can see this was your tertiary 3 degree and now this is your secondary. If you will see with respect to this. Got it, both of you?
Yes, sir.
Yes or done with this? Yes or no?
Yes, sir.
Okay. Moving to the next topic after nomenclature, then it is your nature of CX bond. Nature of CX stand for, you know that is for halogen. Nature of CX. Now see, this is your CX and this is your free bond. Halogens are more electronegative than carbon. This is your carbon's electron and this is your halogen's electron. But after some time, halogen is more electronegative, so it will have delta negative and it will have delta positive. Because basically, the carbon's electron will be attracted towards halogen's electron, halogen side. So there will be delta negative charge and delta positive charge. That shows that this is a polar bond. I think you are aware of this polar and non-polar. Non-polar, that means uncharged or neutral, and polar means charged or charged species. Have you got it?
Yes.
Yes, sir.
So nature of CX bond is polar in nature. Now I'm going to give you some question. Basically, this is also theoretical. This concept you will understand with the help of question. Arrange the following in order of increasing or decreasing. You can take in increasing or decreasing. First, bond length of CX. I'm going to write the question. You can see you have CH3F, you have CH3Cl, then CH3Br, fluorine, chlorine, bromine, and then iodine. You are going to arrange this in increasing order of bond length. And you can do this easily, I think so. Are you done with this? See, one thing is common, which is CH3. CH3 is common. Now you have to decide with the help of fluorine, chlorine, bromine, iodine. Now, they are from the same group. Yes or no, Austin and Humamuddin? Down
Yes,
the
sir.
group, size increases. Down the group, size increases. And if size increases, that represents bond length also increases. So iodine is the largest one, so it will have the longest bond, then this, then this. Are you getting my point, both of you?
Yes.
Please do write this. After this, you are going to arrange them in increasing order of CH. Bond enthalpies, that means basically bond energy. Are you done with this? See, the next concept you have studied in chemical bonding, that is, bond strength or bond enthalpy is inversely proportional to bond length. The compound which have greater bond length or longest bond length can be easily breakable. Are you getting my point, Austin and Humamuddin?
Yes.
Please do write it. After this, you are going to have this. See, I'm going to write this first. In the same order it will be. CH3F, just wait a minute. Inversely proportional. That means CH3F will have the largest bond enthalpies, then CH3Cl, then CH3Br, and then CH3I. Let me know when you're done with this. Are you done with this up to B? Yes or no?
Yes, sir.
Yes, sir.
Dipole moment. Now the next is your dipole moment, and mu is equal to dipole moment is mu is equal to Q into D. This Q charge is due to the electron negativity difference, and distance is the bond length we take. Okay. So generally, in mind, we think that fluorine is the most electronegative element, so it should have the highest dipole moment. But at the same time, the answer is wrong. It will not have the highest dipole moment, but the second highest dipole moment. So the first highest dipole moment will have CH3Cl, then CH3F, then comes your bromine. Down the group, it decreases except this fluorine and chlorine you can see. Here, chlorine, see what happens here. CH3F. It should be, but it is not. Okay. CH3Cl is dominant over CH3CF because chlorine is also the fourth most electronegative element, and the bond length is also matters. That's why. Please do write it. Let me know when you are done with this. Are you done with this?
Yes.
Yes.
Okay. Now see the next topic that I'm going to write here. Now we are going to start methods of preparation of haloalkanes. MOP. In short, I write MOP. Alkanes. See, in organic chemistry, whatever is the chapter, first we are going to learn the name of the chapter, what it is, actually which functional group it is. Then generally we do the structure and nomenclature. After that, we see the MOP, methods of preparation. And after methods of preparation, there are various ways to prepare haloalkanes. After this, we will study the physical and chemical properties. So here I'm going to start the methods of preparation of haloalkane, and the first one is from alcohols. And there are various ways to prepare haloalkane from alcohol. So since we have very less time left, so I'm going to write this, and I will also try to explain, and the rest part which will be left I will cover in the next class. Okay, Austin and Humam.
Yes.
Yes.
Okay. So from alcohols, so this is your alcohol. Everyone knows that OH present in hydrocarbon, that is alcohol. If you are going to treat alcohol with HCl in the presence of ZnCl2, in the presence of ZnCl2, you know what will happen? It's very easy. You need to prepare haloalkane. Halo means X, or halogen, fluorine, chlorine, bromine, iodine. So what you need to do, just replace this OH with Cl. So what you will get RCl. And you know, this OH that will be removed from here, and H that will be left here, it will combine to form H2. It will combine to form H2. Are you getting my point, both of you?
Yes.
Very easy. You just need to replace. You just need to keep the reaction in your mind, and you can easily do it. In the next chapter, that is alcohol, you will come to know that this reagent, basically in organic chemistry, reagent is very, very important. If you have the same reactant, but if you are going to change the reagent, the product will change. So this reagent is very famous and it is known as Lucas reagent. It is known as Lucas reagent. We will study more about this in alcohols, phenols, ether, next chapter of organic chemistry. So this is the first way to prepare haloalkane from alcohols. The next from alcohol is, if you are going to treat alcohol with NaBr, sodium bromide, in the presence of H2SO4, what you need to do, it's very simple. You just need to prepare haloalkane, right? So this is your alkane and you just need to replace OH with one of the uh, halogen from the reactant, or so it will be RBr, and the rest part will be NaHSO4. These are byproduct which is not that much important. Okay, like this. You know what happened here? NaBr. This Na, this height. See what happens. What happened here basically? OH is removed from here, and Br come to attack on this. Now OH is independent right now. Now one of the hydrogen from here will come and combine with OH to form water. Now what it becomes? HSO4 minus. It becomes HSO4 minus. When Br moves, Na will be in Na plus. So it combined with this to become NaHSO4. Basically, we don't deal with the byproduct. Main product is very, very important. Got it?
Yes.
The third reaction, alcohol, to make basically to prepare haloalkane, you are going to treat this with PX3. PX3 is phosphorus trihalide. So what it will be? There will be 3 moles of RX and then H3PO3 will be formed. You know, very easy it is. How I wrote this reaction, it's very easy. You can see here that there is basically P and there is X. This is your PX3, and there is 3 moles of ROH as well. 3 moles of ROH. So you know what will happen? This 3 and this X will combine together. So it becomes 3 moles of RX. Okay. Now what you have left? You have left OH, 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 and this P. So basically H3PO3. And in this reaction, this byproduct is important. Okay. Please do write it. Are you done with this?
Yes, sir, done.
Okay. Austin?
Yes, sir.
Okay. The next reaction, you are to prepare haloalkane, you are going to react this alcohol with PCl5. So what you will get, it's very simple. You are going to replace this with RCl, and there will be POCl3 as well as HCl. So in these two reactions, there are some questions that has been asked about the byproduct as well. So please be prepared for this. So just write the last reaction. There are various more concept to these reactions that I will be taking in the next class.